ಯಾರ್ದು ರೈಟ್ ಬಾಲಾಜಿ ಫುಲ್ ಖುಷಿಯಾಗಿದೆಯಾ? ನಿದ್ದೆ ಮಾಡಿದ್ಯಾ ಚೆನ್ನಾಗಿ? ನಿದ್ದೆ ಮಾಡಿದ್ರೆ ಖುಷಿಯಾಗಿರ್ತಾರೆ. ರೈಟ್. So what we have discussed, subroutine discussed, done. We have to discuss. Did we mention what are the subroutines? RET. I was just thinking in other direction like this. I will link both the things now, but you should remember the architecture for this. Remember architecture? 8051 architecture. We'll draw it here. ALU is there. ALU is connected to A and B register. A and B registers are connected to internal data bus, right? Internal data bus. And ALU is also connected to one more thing, PSW. So this register is here. Next, after that, what is there here? RAM. What is the size of the RAM? 128 bytes of RAM, 128 bytes of SFR. Together there is a set, one set. That is also connected to internal bus. This is the internal bus there. So A and B registers are connected, PSW is connected, RAM is connected. This is all on the top. Anything else on the top? There is a down part here. The two registers are here. What are the two registers? PC and DPTR. Both are 16-bit register. And next to that, there is a ROM, 4 KB of ROM. Both of this, including ROM, they are also connected to the internal bus of 8-bit and address bus at the bottom. Right? Now this address bus and internal bus are connected to, so let's speak about only internal bus. Is connected to internal bus only, not address bus. Bottom is address bus. Internal bus has both data and address. The internal bus. Internal bus gets connected to all. Goes to only port 0 and port 2. For that we have first latches L0, L1, L2, L3, and then we have pins. Now, in here whatever we have said, RAM, SFR, A register, B register, PSW, ALU, DPTR, PC, ROM. In all this, you know the instructions, correct? How do we move the data in the RAM? You know it. How do you work with the PSW? You know it. Set a carry, auxiliary carry, why it is used, overflow flag when it is used, parity is when it is set, the RS0 and RS1. Do you know RS0 and RS1? Where it is used? Selector register bank. In the RAM, we have 4 register banks. Typically, we will be dealing with register bank 0. If you want to register bank 1, we will select RS1 and RS0 and go to register bank 1. So we know how to deal with the PSW. We know how to deal with A register and B register. And we know how to deal with the RAM. We know how to deal with SFR. We know how to deal with the DPTR. We know how to use a PC. There are only 2 instructions for PC. Move PC, that you know. Then we also know what is the use of the ROM. What we don't know in the whole architecture is what is P0, L0, P1, L1, these guys are doing. In this discussion, whatever we have done with respect to the addressing mode or type of instruction, we know. Yeah, I know it is an arithmetic and logical. What it has inside? It has only adders. It does not have subtractor. It does not have subtractor. Anything you say as a CJNE or that of this instruction, it is finally addition. What is the effect of that addition has to be decided. Is it clear? That subtraction is finally addition only. Comparison is nothing but subtraction. That subtraction is nothing but addition. You are getting the point? Are you clear on these points? So we know every part now. PSW we know, A register, B register, ALU, RAM, SFR, DPTR, PC and ROM. What we don't know is these things. How to deal with L0, how to deal with P0. What is the difference between L0 and P0? We don't know that. Right? So today we'll try to deal with that. So from here we gradually move towards C programming. Right? In another 1 or 2 classes, we'll gradually move towards C programming. So I have sent a list of programs to all of you. They are basic fundamental programs. If you feel the moment, if you can write those programs without seeing any reference. If I give you a white paper, you should write it now. Right? With an understanding. You should not be only like, if I ask do some changes. For example, there is a block move. Right? If I ask you, take this block and take this block, add them and put the result in another block. This is the application of that. Block move is same concept. How do you do the block movement? Read this, copy here. Read this, copy here. Right? Instead of that, I am asking you, there is one block from 30 to 34, another block from 40 to 44. Add the basic, the content of these memories and so, can you write this program? That should be the ability. These are called fundamental programs. If you can write them without seeing any reference, that means you are comfortable with the subject. And you should also have visualization, proper visualization. Without visualization, if you can write a program, if I ask you some changes, you cannot visualize, gone. Okay? Right? So all of you need to practice, understand and practice, and then like make sure that you write them without seeing any reference. These are the fundamentals. Are you clear? Right. So on this we can do some application programs. Like one I said is an example. If I change some concept in that, you should be able to write. That gives you the confidence. This all programs has to be done in the lab. I have went through Monday lab is pretty lagging. The Friday and the other labs they are good. So there are totally 27 programs. In that 27 programs, Monday lab they have done only 17 programs. Correct? 17 or 16 you have done. 16, 17. Yeah. So others have done little bit in higher number. Please ensure that like they are finished by this week. From next lab we will gradually move towards C. If you lag behind, then like we'll not discuss this assembly again. We'll start discussing on C. No more instruction sheet, no more this thing, gone. Okay? So please ensure now this is a high time. This is the last one that I can give you. Right. Now today in this class we'll concentrate on that. Port zeros, P0, P1, P2, P3, L0, L1, L2, L3. Now, if you go to the kill, where do you see this port? There is two options. One, you can go to D colon or I colon, right? 0x80. Because you know the port address as 80 port. That is one way. The other way is, there is a peripherals. In the view, edit, on all top, file in this, the peripherals. In that there is an IO port. In which, if you click on that, it will show you two things. Port 0 and pin value. So it's two things. One is port 0 and another is pin value. They are two different things because this port 0 refers to D flip-flop associated with every pin. You remember? What is the default value of the D flip-flop? Default value in the sense like when we reset. When we reset, there are only few registers which does not have the 0 value in whole system. One is SP. SP is not 0. It is 0, 7. The other is ports. All these ports will have 1, 1 by default. If it is 1, whether they are input ports or output ports. We have discussed this. If it is 1, port 0 is 1. Whether it will become input port or output port. Please see and let me know. Do you have the documentation? We have written if D equal to 1 and then like clock equal to 1 or rising edge or falling edge, then what happens? Then what happens? Or you should imagine what is the structure. If D is 1, no. When D is 1, what it can be? Just tell me that. All of you should say only one thing, input or output? D equal to 1. Is it there? Can you analyze it? D equal to 1. Please see, this is very important. D equal to 1. It's an input port, right? Now listen to me back. D equal to 1. Q bar 0. Connected to NMOS. Not the NMOS is off. NMOS is off. On P1 is the easiest port is P1. Easiest port is P1, right? On P1 we need a pull-up resistor to make it as an output port. Make it as a input port or output port. Yeah, see, this is the point. The below is not connected to ground. That means whatever the signal coming from the Q bar is not enabling this transistor. Transistor is off. That means which connected to this it is floating value now. We have to put one resistor here and make it pull up. Correct? You remember this concept? So by default, we are not making this port pin a certain value. It has to be defined by this side. So by default, all the pins, if they are 1, 1, they are input ports. Did you got it? Otherwise, there is a document that we have discussed enough. Please refer to that. Right? By default, all the pins are set to 1, 1. That means port 0 is FF. Port 0 is 1, 1, all 1, 1. That means it is an input port. When it is an input port, move A, P0 will work. From P0 will become source now. Will become a source now. You are taking the value to A. Now which will come? Whether this value will come or this value will come. As an input, when it is an input, this value will come. This is only for setting the port, whether to make the port as input port or output port. Did you got it? This port 0, we are setting the D flip-flop to make sure D flip-flop is only for setting. Guys, you are clear on that, right? The data will not go through D flip-flop. Right? There is a read latch, there is a write latch above and below. Through that it will go. Right? This is a D flip-flop. This is a pin value. If you make this all 1, you can do this as a read pin. All these values will be set by an external entity. Then you should read the value from here. How do you read P0, A? This will become the source. Otherwise, if it is all these are 1, 0, zeros, then it is an output port. You can put the values out here. So how do you do that? Move P0, A. This is a simple instruction. Internal content we are putting to the P0. But there is a slight possibility of confusion. Bharat should give an attention here. First time when you put a value to P0, it is a configuration value. First time when you put a value to P0, it is a configuration value. Next time you put a value, it is a pin value. Did you got it? If you want to send FF through these pins, so first what you have to do, move A, #0 FF H. First step, what has happened? We are configured now. No, sorry. Port 0 this has to be 0, right? Move A, #00 H. Then move P0. Now we have configured a port to become 0, 0. This will all get 0, 0. First step. Next you can put the value. Is it clear? How do you put a value? How do you configure the same procedure? That is a slight confusion you might get. But is it clear? Is it clear? Right? Is it clear? So, this experiment that we discussed today, you should try that in the lab, next lab. So, by default, all the pins are 1, 1 and they are input. Now, I want to make them as output. So, I have to put 0 to them. First time when I put a 0, it is a configuration. Next time when I put some value, then it is a value which goes out. Is it clear? Please write this statement. Ports. Port programming. Programming the ports or port programming. What we are discussing today is port programming. What we are discussing today is a port programming. How do we program the ports? Because we know how do we program the RAM, internal RAM, external RAM. Oh, external I have not spoken. External RAM also you know how to get the data from the external RAM and write the data to external RAM. MOVX instruction, right? This right? End ಬಗ್ಗೆ ಮಾತಾಡ್ತಾರೆ. Yeah, you have written port programming. Before start writing this, please go back. Which program was that? Insert an element. We have said yes jump to last. Something we said. What is the thing? And we have given that label to end. End cannot take any label because end is not an instruction. End is a directive to an assembler. You are getting what I am saying? ಏನಿತ್ತಲ್ಲಿ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಏನು ಕೊಟ್ಟಿದ್ವಿ? ಇಲ್ಲಿ ಲಾಸ್ಟ್ ಅಂತ ಎಲ್ಲಿ ಕೊಟ್ಟಿದ್ವಿ? J and Z last ಅಂತ ಬರೀರಿ. There is a instruction J and jump on non-zero to last, and last is given to end. End we cannot give a label to end, neither to origin, because they are not instructions. That is a mistake that we have done. Please correct it. J and Z last, somewhere in the middle of the program, and we have given last to end. This end we cannot give an instruction. What end you put here, put a knob here. No instruction. If we leave it also, it will take knob only. That we tested. Yeah, thank you. But you should know why you cannot give the label to the knob. Sorry. Why you cannot give label to end? Because end is not an instruction. End is a assembler directive, which is we are telling assembler to finish its program here. Is this clear? If it is not clear, please write one statement. Because if we do some mistake, it is very much required that we clarify the mistakes 100%. Right? Note. Label cannot be given to assembler directives. Label cannot be given to an assembler directives. Like end. Is it clear? Right? Let's go to program. What is the program that we will try to write today is, we will try to blink one LED. This is all like experimental program. All that we have done is all internal. Internal architecture, internal to the architecture, we did some data movement and we did some calculation inside the memory. Now we are coming to the external world. How this microcontroller will speak to the external world. First simplest thing is connect one LED. Try to blink that LED. Second easiest thing is connect one switch button. Press a switch, LED should blink. Now you know how to blink an LED. Now depending on it should happen. Or otherwise, press a switch, addition program should happen. If you don't press a switch, subtraction should happen. You are understanding? Now like this, we'll take the inputs from the external world. You understand what is the external world, right? LED and the switch are external world. Okay? Right. The external world is for 8051 is external to the 8051 IC. Okay? Right. So write a program, please write this statement. Write an assembly program to blink, which is a port 1 will take. To blink an LED connected to, port 1.1. Only one LED we are taking. So it has to be connected to one pin. Port 1 is 8 pins. Port 1.0, not 1. That is the first pin of the port 1. Okay? Right. How do we do this? Same concept. ORZ00H. This you should remember. Move A comma hash 0FFH. Move P1 comma A. Move A comma hash 00H. Move P1 comma A. Set a port as input port, set a port as output port. Correct. By chance, if you have converted that to this one, what is that? Output port. And again you want to make it as input, then this is the thing. Is it clear? Right? Please mention these two separate things. Whenever you do this first time, it is only to set it. Next, you can send a value. Right? Okay? Done? Right. Now what we want, we said like, we said this actually. What is this? This is 8051 IC. It has port 0 and port 1 on this side, right? Port 0, port 1. Port 0, 1, 2, 3. Port 0 is here, port 2 is here, port 1 is here, port 3 is here. Correct. Correct. Right? So, this pin will be here, port 1.0. Which is the pin number? 1 only. So, pin 1, we have to make that pin, we'll connect the LED to that pin. One LED to that pin. The other side has to be grounded to complete a circuit. Right? This is a visualization of the program now. Till now we used to visualize it what is internal to this. Now we have to visualize it what is external to this. Is it clear? What we have to do is this connection. Okay? Now what we have to do? First step, what we have to do? Huh? What is the first step that I have to do? Configure the port as output port. The output is. See, guys, I will tell you the point. Why this is so important is because this LED is single LED. Whatever you are getting a high definition LED TV, there are 4K LEDs in that. Conceptual idea behind them, driving that behind that 4K LEDs is same. Just blink. With what color? If this is, there are colors in this, like with what color is another question. Come here. Nikhil, this should be the last warning for you. Whatever it is. I don't care. Like I found that there is something wrong, I'm just giving you a warning. Make sure that next time you are on safe zone. Right? So that is where it is very important. One aspect. The other aspect is, now you remove LED. Connect a motor to this. Only thing is, this power that comes from here is very minimal. That is 5 volt. It will be around 5 volt. The signal, if I make it as 1, it will be 5 volt and some 0.5 amperes or less than that current rating. Your motor will run at high current rating. So what you require is one relay here which will switch the high current rating device. But again, inside the conceptual idea, same. That is what is important. Whatever you do, you want to make a pin on or off. This is the concept finally. LED on off concept is you are making a pin high or low. Now you leave this concept and take the square wave generation. You want to generate a square wave. How do you do it? Same concept, pin on or off, connected to oscillator, you will see a square wave. So many different things are possible. Only one application that we are speaking is LED. Okay, right? Now let's see to this. First thing, what should I do? What is the first step I should do in the programming? Configuration of this port pin. How do I configure it? I want it as an output port. Output port. So what should I do? Move A comma hash 00 hash. Move P1 comma A. So by this I have set it as P1 as output port. Okay. By this we have set the P1 as output port. Now I can put the value to the P1. Okay. What is the next I should do? Bharat. No, whole port we are making it as an input port. What you are saying is make only this pin as an output pin. How do we make that? Oh, one more point I should be precisely telling you. There is no instruction like this. In your instruction sheet, if you search, you will not get an instruction wherein which move P1 is there, but there is an address register. P1 is never understood by your controller this directly. So this is actually written as, it will replace it as 0x90. Who will does it is compiler, the assembler does it. That is why you can write this instruction. But if you check in the instruction set, there is no instruction called as move P1 comma A. Is it clear? Right? This is only the support from the assembler or a compiler that you get for ports, not for all. Okay? Is it clear? Please make a point here if you are there is no instruction. There is no instruction. There is no instruction as with P1 as a destination register. P1 register as a destination register. There is no instruction with P1 register as a destination register. But in direct addressing mode, we have move address comma A. Move address comma A. This statement is clear. This statement is clear. Move address comma A. That is clear. Right? Done. What is the next step? There are two ways now. We are very clear that like all these port registers are bit addressable. Correct? All the port addresses or registers are bit addressable. And they can also be byte addressable. Now it is your choice to make whether you want to do it as a bit addressable or byte addressable. The easiest way is bit addressable. How? There is one instruction called set B. Set B, and then there is address. So in that I can say P1.1 port 1, 0. Port 1, first pin, set that. Okay. Then what should I do? I have set means LED will glow. Next, CLR C1.0. Don't write it, don't write it. Don't write it. We have set it, this is glowing. Now we have cleared it, it is off. Correct? Then what I have to do? Repeat this infinitely. How do I do it? Simple. Yes, jump here. I will give here. Yes, jump. It will come here. It will jump here. It will come here. It will jump here. This keeps rotating. Right? At the end, it is end. Is it clear? This program is simple. Don't write, Janavi. Don't write. This program is clear. Right? Now, what Dhanush is saying or Balaji is saying is, we should call delay. Why we should call delay? My intention, you tell me how long it will be on. It depends on the frequency with which this guy is operating. In that again, what is the standard frequency? 11.0592 megahertz. Correct? This is the first base. Basically, this is the reason. But we are not directly connected to this. To machine cycles. Why? Because each instruction will take certain machine cycles. Right? Base is this, 100% base is this, because machine cycle where we will get like this only. Okay? So now we should find out what is the time taken for one machine cycle. What is the time taken for one machine cycle? Yes, to? Tell me in times. How many seconds or like hours or milliseconds or microseconds? Tell me in hours, brother. Tell me in time axis. What is the time taken by one machine cycle? 25 minutes. Is on it, no? Now you have to tell me how you have calculated that. How do we calculate it? Guys, listen. Frequency of the machine cycle is what? Divided by 12. Divided by 12, what will we get? If I divide this by 12, what will we get? 921600 hertz. That's all. Okay. Now this is by one machine cycle. Now the instructions like set B, clear, are one machine cycle instructions. Right? In such a case, they will take how much time? 1 by this value. What will be the value? Huh. 1.08 microsecond. Correct? Time will go here. Color up this part. LED things. Huh? Now this will execute in what time? This will execute in one machine cycle. How do I know this? This is given in your instruction cycle, instruction set. Right? It is in instruction cycle. How many oscillator cycles it will take? Is it clear? If you have do you have instruction set? All of you have an instruction set. Can you quickly tell me how many clock cycles does this take? Who will tell me? Hitesh. 6. Hey. It is there in the instruction sheet. Oscillator period. Oscillator period. It is there, yaar. 2 machine cycles. 2 bytes is there. 2 machine cycle is there. There are 2 aspects. Guys, see here. Guys, see here. Listen to me first. Every instruction, when I write every program, there are two aspects, engineering aspects. What are the engineering aspects? Time and space. How much does that instruction or a program take? How much space does that instruction and program take? For that, yes jump instruction. You know why it is 2 bytes. Yes jump. 1 byte for this, 1 byte for this. Because this is 8 bit. Correct? This we have discussed enough time. So this is 2 byte instruction in the memory space. Now if it is 2 byte instruction, sometimes it might take 2 machine cycles or only 1 machine cycle. Now you should tell me that. It is there in the documentation. 2 machine cycles. Sure? All of you are sure? Right. So 2 machine cycles here. And what about clear? CLR? So 1 machine cycle for this. So this takes 1 machine cycle, this takes 1 machine cycle, this takes 2 machine cycles. Altogether it is 4 machine cycles. That means 1 point something into this microsecond into 4 microsecond approximately. 4 microsecond this program is looping with time delay. What is the time delay that it does? It takes 4 microseconds. In 4 microsecond it ons it, offs it, and you will not be able to see it. What is your real time value for I? Huh? What is the minimum time delay for your I? This thing to understand what is changing. Yeah, general understanding it is 1/10 of the second. If something changes within 1/10 of the second, your eye will not be able to identify that as changing process. You are understanding? So what is that you want? 0.1 seconds you want. At what it is operating in seconds? 0.00004 seconds. It is operating at this second. It is, you want it to, your eyes can understand only this second. Right? So, somehow you should make it to operate with this time delay. So that your eyes can understand like, okay, it is blinking. How do you do that? Huh? Call a delay. How do you write a delay program? Yeah, I don't know how to write a delay program. Is it clear? Does this point is clear? See, the point is this. Call a delay is correct. But why do we call a delay and what is the quantification of values? These are the quantification of the values. Engineering is all about quantifying something. You can speak in general. When I say program writing is a logical process, it is a pure art. Pure art. You have read like a lot of stories or movies. There has to be logical process between each scene, right? Then only you will see it as a film. Continuous story has to run. Same way you write a program. By understanding, he will understand some English words and put some high intensity words and low intensity words. You write XCHG and direct move in here. That is an art. It is not engineering. What is engineering in that is this. How much time it takes? How do I reduce the time? How do I optimize the time? Not reduce only. Optimize the time. How do I optimize the space? These are all, wherever you go, you will come down to only these two things. Engineering challenges are only two. Basically only two. Now they have added power and this and all. Like basically there are only two. How do you deal with the space? How do you deal with the time? Okay, clear? So we are just quantifying it. So please understand this quantification. That is important. Now we'll write a call delay program. In textbooks it is there, but it is independent topics are there. There is no connectivity. I am just connecting those topics. Okay. Right. So what we do now? We need to do the delay. Okay, there is another way of writing this program that like we will send a value to whole port. That is 80, no, 01. A holds 1, put that 1 to P1, output port is always destination side. Then like make A hold 2, A holds 00 and move P1 comma A. This is there in your textbook. This program is there in your textbook. Okay, but I have not tried by writing set bit and clear bit, but conceptually or logically it is right. Previous program that I have written using set bit and clear bit, I have not tried that, tested it, but this program I have tested it, it works. Right, please write down this program, but with the concept of that 4 microsecond and your problem of this thing. So you all of us have a eye problem. That is your final conclusion. Yes, right, Chetan? Correct, huh? You should not accept whatever I say. Done? Quickly guys. So we found out that there is a delay loop runs at, now with this inspection there are 2 more, 1 machine cycle added. So 6 microsecond. Total time delay is, here is 1 machine cycle, here is 1 machine cycle. Somehow, right? If I calculate all together, it will become 6 machine cycles. 6 into that 1 microsecond, 1.08 approximately, we'll take it as 1. It will be around 6 microseconds. Till then it is not a solution. So what we do now is we'll write one small delay program here. What is a delay program? What is a delay program? We'll say, right, we'll write some delay here. Delay program we'll write. Then like move A comma hash 00h. Move. Should I have to write delay here? Guys, listen. What I have made here is, I have made port 1 0th pin as high. Then I have called a delay. Now I have made the port 1 0th pin as low. Then I have to call delay, or like should I have to jump back again? Why delay is required? Whenever, otherwise it will go back again here. You will not see whether it has gone off at all. You want to see some operation, then there has to be some delay. Delay and then S jump. S jump here, then end. Now what about this delay? You are writing this program? Good. I will gradually make changes and go to the last version of it. Till then, like, hold on. This delay, if I write delay this like this, it will throw an error. If I write delay like this in our assembler, it will throw an error. You cannot write like this. What you can write is, but the indication is that you should write some delay here, right? As delay is one standard program, listen to this very carefully. What we do in delay is nothing. We'll just waste time. We have nothing to do. We just want this LED to blink, that's all. As it is not visible, so we have to waste some time of 8051, not ours, 8051, right? Of 8051 and come back, turn off the pin and waste some time. Then like jump again back so that like we'll see what is happening inside 8051. Is it clear? Is it clear? So how do we waste the time? Tell me. Bharat, how do we waste the time? Oh, like that, like you are telling with respect to 8051. I was telling about you and me, how do we waste the time? Knob. What is knob? No operation. No sleeping, you cannot say sleeping, it is a very good operation. Subroutine I don't understand. Right guys, see, what we do is, did you ever heard of like spoken to psychiatrists? Why are you saying towards her? Who? Channavi? You don't know. He is seeing towards you when I say like, did you ever spoken to psychiatrist? You are a psychiatrist. He is your patient. No, he looks like a patient. Guys, listen. They say, this is just an analogy that I can give you. Whenever you get an anger, right, count from 10, 11, 10 to 9, reverse, or 100 to 0, reverse, right? So what we do now is also the same thing. We will count, now we'll not do anything just but like we'll count. We'll count from, what is the maximum number that we can do? Is FF. FF to 0, FF to 0. That's all. What is the use? No use. You getting it? So how do we do it? Move R3 comma hash 0FFH. Right? What we do? D, J and Z. R3 comma BMS. Where is BMS? BMS is for DJ and Z1. Right? What it does now? R3 is FF first instruction. Next what it does? It will reduce R3 from FF to FE and it is not 0. It will jump to BMS. FE to FD. Like that it keep on reducing, goes on reducing. So how many cycles it will take to complete this instruction? How many cycles? For example, first thing is, how many machine cycles this instruction takes? Guys listen, the first point is, to execute this once, how many machine cycles it will take? Search here. DJ and Z like oscillator machine cycles. Not brought the instruction sheet. You brought it. Two machine cycles. Sure. 2 is sure. So to execute once, it will take 2 machine cycles. Now you tell me how many times it is executing. Jora hello, like I cannot hear. 256 he is saying and the Krishna is saying 255. Which is true? Huh? 255. You are saying 255, right? Don't change it now. Huh? 255 is there, right? You keep on reducing till 1. 251 to 255 is 255 times, right? When it is 1, R3 value is 1, it will execute one more time. It will execute this instruction one more time to become 0. Then again if you do it, like it will come out. You got it now? It will exactly go for 256 cycles, not 255. Got a reason? 1 to 255 is 255 times. 1 to 0, one more 0 is added in that series, so it will become 256 times. So this instruction will execute 256 times. That means 2 into 255, 256. 2 machine cycles for each cycle and 255 times it will do it. You got it? So what is the number? 512. Plus what about this guy? 1 machine cycle or 2 machine cycle for this? 1 machine cycle. R3 comma immediate. 1 machine cycle. 1 machine cycle. Chetan? 1. Chetan said 1, it is 1. So 513 is the number of machine cycles it takes. Right? Each machine cycle will have 1.08 microseconds. What is the value now? Huh? Almost 513 microseconds. Almost 555. Okay, 555. Microseconds or milliseconds? 555. Microseconds. Hey, micropa. Because I have removed this. If you want in this one, like you have to make it as this. Right. What is your I problem again? 0.1 second. You want in 0.1 second. So how many seconds is this? Again, there is a problem that like 3 zeros and 3 5. This is still not sufficient. You cannot see what is happening. D1, if I counted from FF to 00, the still delay is not enough to that I can see it. So I have to do one more this thing. What will I do? Huh? Switch it on. This all together will not take much time here. One thing. Second thing, I want delay only here. If I take it from here part. No. One thing. Hold on to your point. I will conclude this. Then you can ask this question. Dividing the clock frequency will take the next method. We will come to that. Right now, what we are doing is simple time wasting. Okay. That is a very good option, but we'll take in the next topic. And we should say this and say what is the disadvantage of this and go to that. Okay. Right. How do I do one more cycle wasting is like this. Move R4, hash 0FF H. Right, see to this now. DJ and Z, R4, Balaji. Okay, now where do we will put the Balaji's name? We'll put Balaji to this. You are not the only Balaji man. There is a big don there sitting in Tirupati whose name is also Balaji. Right? Right. Now see what is the trick. This will execute till R3 goes to 255 to 0. Right? R4, if it is 255 to 254, it will go back here and again fills this and executes this for 255 times. You are understanding what is happening? Loop within a loop will make this to execute how many times? 256 into 256. Got it? How many times this will execute? How many times this will execute? 2 into 256 times. Why 2? You know it. This is one machine cycle, this is one machine cycle. Now let us see at least we have reached our target or not. 256 into 256 into 2. How much? 1315 255 into 255 into 2. Correct? 255 into 2 is 512. I added idena one machine cycle plus 2 into 1.08 microseconds.